All right, today we're going on a really special kind of tour. We're going to explore the architecture of the human heart. And our guide for this journey? The absolutely stunning illustrations from Rouvier's classic anatomy text. So think about it for a second. We all know the heart is basically a pump, right? It's our body's most vital engine. But what does it really look like on the inside? I mean, how is this thing actually designed? We're about to pop the hood and explore the blueprints of the machine that keeps every single one of us alive. And here it is. This is what we're talking about. Just look at this illustration. You can see right away the heart is so much more than just a simple pump. It's this complex, almost sculptural thing with these massive vessels branching out like the roots of a huge tree. And it's all wrapped up in this protective layer. It is, no joke, a masterpiece of biological engineering. Okay, so first up on our tour, the heart's location and form. Before we go inside, let's figure out where this thing actually lives in the body and get a handle on its basic shape and size. You're looking at a chest X-ray here, and that shadow right in the middle, that's the heart. It's nestled right there in the chest in a little neighborhood between the lungs called the mediastinum. And you can see why it's in such prime real estate. It's the perfect central spot to pump blood to, well, literally every corner of your body. And for all that power, you'd think it would be huge, right? Well, get this. The average adult heart weighs only about 265 grams. A bit more for men, a bit less for women. To put that in perspective, that's less than a can of soup. It's just an amazing testament to how incredibly efficient this organ is. Okay, so what about its shape? Well, the best way to picture it is to imagine a pyramid, but it's been kind of tipped over, so the wide, flat base is actually at the top. That's where all the big blood vessels hook in. And the pointy tip, what we call the apex, points down and a little to the left in your chest. And hey, that's exactly why you feel your heartbeat strongest on your left side. All right, we've seen the outside. Now for the really cool part. Let's move on to the four-chambered engine. We're going to peel back those walls and step right into the engine room. And this comparison is just perfect for showing what I mean. On the left, you've got that muscular exterior we've been looking at, but look at the right. That's a cross-section, and it reveals a huge secret. The heart isn't a solid block of muscle. It's actually hollow. It's got these internal rooms or chambers, and that's where the real magic of circulation happens. So the heart is basically a four-room house. You've got two chambers on top and two on the bottom. The two upper ones are a bit smaller, and they're called the atria. Think of them as the receiving rooms for blood coming in. Then you have the two lower, much larger chambers, the ventricles. These are the powerhouses, the big pumps that do the heavy lifting of sending blood out to the rest of the body. This view gives us a really clear map of those four chambers. You can see them all laid out. On one side, you've got the right atrium and right ventricle, and on the other, the left atrium and left ventricle. But look closely at the walls between them. You see how thick they are? They are absolutely crucial for making sure everything works the way it's supposed to. Okay, so these dividing walls have names. They're called septa. The wall between the two top chambers, the atria, is called the interatrial septum, and it's pretty thin. But now look at the wall between the two bottom chambers, the ventricles. That's the interventricular septum, and it is a thick, powerful wall of muscle. And there's a really good reason for that. The right ventricle only has to pump blood next door to the lungs, but the left ventricle, it has the massive job of pumping blood to your entire body, so it needs that extra muscle to generate way more pressure. So we've got our four rooms. But how does blood move from one room to the next without getting all mixed up? That brings us to our next stop, the valves and blood supply. We're talking about the heart's incredible system of one-way doors and its own personal fuel lines. This is such a cool perspective. What you're looking at is a top-down view of the heart, but with the top chambers, the atria, completely removed. And what that reveals are these four crucial heart valves. You can think of them as the heart's bouncers or gatekeepers. They have one and only one job: open up to let blood flow through and then slam shut to make sure none of it comes backward. And the way they work is both simple and totally perfect. It goes like this. A chamber fills up with blood, then it contracts, which builds up a ton of pressure. That pressure forces the valve ahead of it to pop open. Whoosh, the blood flows through. But then, the instant the pressure changes, any blood trying to slosh backward just pushes the valve flaps closed. It is a completely flawless one-way system. Nothing gets back in. Now, you have to remember, a muscle that is working this hard 24/7 needs its own fuel. It can't just run on empty. And that's exactly what these are, the coronary arteries. You can see how they're spread all over the surface of the heart. They're the heart's personal fuel lines, delivering a non-stop supply of oxygen-rich blood right to the heart muscle. And that, of course, is why a blockage in one of these tiny arteries is such a big, big deal. Okay, for the final leg of our tour, let's talk about the building materials. What is this incredible machine actually made of? We're going to look at its muscle, walls, and casing, the specialized muscle, the internal skeleton, and the protective case it comes in. So the vast majority of the heart's wall is made of this really unique muscle tissue. It's called the myocardium. And it's not just strong, it's incredibly strong. But here's the most amazing part. It contracts involuntarily. You don't have to think, okay, beat now. Nope. The myocardium just does its job all day, all night, without you ever having to give it a single thought. And the heart isn't just a big bag of muscle either. It has structure. It has an internal framework, what we call the fibrous skeleton. You can see it in this diagram. It's kind of like the foundation of a house. It's this dense framework of connective tissue that gives the heart its shape, provides a strong anchor point for those valves we just saw, and, this is super important, it acts as an electrical barrier between the top and bottom chambers. And speaking of electricity, check this out. This is basically the heart's electrical wiring. It's called the conduction system. You've got these little nodes of specialized cells, like the sinoatrial node, which you've probably heard of as the heart's natural pacemaker. It generates a tiny electrical spark, which then travels down these specific pathways. This signal is what tells the different parts of the heart muscle exactly when to squeeze, creating that perfect, coordinated rhythm of a heartbeat. Last but not least, this whole amazing machine needs a protective case, right? Well, it has one. It's called the pericardium. It's this super durable, two-layered sac that completely encloses the heart. Its job is to protect the heart from things like infection, to keep it from stretching out too much, and to make sure it stays securely anchored right there in the middle of your chest. And this diagram shows you exactly how that works. You can see how the pericardium fits around the heart, almost like a custom-made glove. But here's the really clever part. Between those two layers, there's a tiny bit of fluid. And that fluid acts as a lubricant. It allows the heart to beat constantly, billions of times in a lifetime, without rubbing itself raw from friction. Just brilliant. So there you have it. From the outside in, that's our architectural tour of the human heart. It really is an almost perfect machine, built layer by incredible layer. You know, understanding the blueprint, the architecture, is one thing. But it leaves you with an even bigger question, doesn't it? Just how does all of this work together to keep us alive? Well, that's a story for another time.